Hello guys, welcome back to this works. That's all today's POTD. So in today's POTD, there is a one thief and who wants to loot money from the houses arranged in line. He cannot loot two consecutive houses and he is aims to maximize the total money. Okay, so this is the array we are given. Suppose like that, like first house contains money 65574. This is the like amount of money, and as we know, amount of money cannot be negative. So that's why the constant are AR of I will be greater than equal 1 or less than equal 10 to the power 4. Also the size is array size is less than equal to 10 to the power 5. Okay. So let's first understand how are this happening. So suppose this is the array. Suppose four houses are there. 4, 7, 5, 3. Okay. So when we thief are at 4, there is one chance he can take 4 or not. He can loot the house he can loot this house or not. Suppose this loot, so we will get money for. If thief loots this house, he cannot get money from here. So now he will be at here. So he will get, there is chance like he will, suppose it is 8. So now if you think, if he gets 4, if he gets this 5, he won't be able to get this 8, right? Because if he gets 5 from here, this will be consecutive, like continuous, so he won't be able to get 8. So it will be when it will be most like it will be beneficial if thief don't loot from here and loot from here, because it will be 8, he will get 8. This is the one solution. If thief don't get money from 4, okay, thief know, like he already know, if he gets money from 7 directly, so what will be the total amount? He gets 7. Now he as he gets from 7, he won't be able to get from 5, and he also get from 8. 7 plus 8, total money will be 15. Here total money will be 5, 12. So thief has to decide like which houses he should loot or which houses he should not loot. Okay. So what we will do, we will use the TP here. Okay. And in this, okay. Okay. Mm. 7, 3, 4, 5, anything. So we will define state of TP. Okay, like what TP of I tells. DP of I tells maximum. This is the very important part. You always have to state the DP, like what DP tells you, like DP of I, what it mean with DP of I. So maximum money thief can get if he is at house number I. Okay, house number I. Okay, so and like, okay, so suppose we are here and thief is starting from here. Thief is like we are writing DP this way. So suppose we are at here, DP of I. What will be the transition? This is a state and what will be transition? We have two cases. First one is loot I. Second is not loot I. Like we get money from house, ith house, and we don't get money from ith house. If we loot money, so we will get total this AR of I money we will get. And now as we get money from ith, we won't be able to get from I minus 1. Okay, so we have to write here I minus 2, because from I minus 1 we won't be able to get. Okay, and if we not loot from I, so we there will be case of I minus 1. So we can go to I minus 1 and decide like what we should do. Like if you are at here, suppose you are at 5, if you get money from 5, there is surety you cannot get this 4, so you have to come directly here and you decide whether you take the 3 or not. This up to you. but you cannot take 4 if you take the 5. Okay, that's why we are saying, like, here it will decide, but as he gets I, he won't be able to get I minus 1. That's why dp of I minus 2. Okay, and if we don't get money from ith, like don't get money from this fifth, so we come to this 4 and we decide like we will get this 4 or not, we decide. So that's why dp of I minus 1, because dp of I, what will tell, it will tell the maximum money that we can get from here. So transition will be what? Transition will be nothing but dp of I equal to maximize, we will, as we are finding maximum money we want, so maximum of dp of I minus 1. This is the scenario where we are not looting I, we will not loot I, and ARR of I plus dp I minus 2. If you loot the money from house, ith house. So this is the second case. So we are taking the maximum from both cases. Okay, this is the basic approach I have tell you. Now if you know the coding part, you can try it with your own. And now I'm going to explain my code also, so you get clear idea. And here I'm not going to implement the recursive ideas because that's simple enough, and I think you can be solved. But I'm going to solve with the iterative approach. Okay, because it's like more easy. It's not easy, but it's don't take extra space and it's already space optimized. Okay, okay, so this is my code. Okay, let me open the pencil also. So if we crop the code from here, so this is the code. Okay, so what this is, n is nothing but the size of array. Okay, and we have defined initialized with dp of n is 0, like everything is initialized with 0. Now I'm going to explain you this one example also. Okay, let's take the example that is given in the question itself. That is, what is 65574. Okay, 65574. Okay, so now what we have done, the maximum money, if you are at here, the maximum money that you can get is nothing but AR of 0. Okay, this is the base case we have written. Okay, now the seven key idea that you can get from this video is, like, if you want to write over state is over transition is like this: dp of I minus 1 and some maximum of, and we are dp of I minus 2 plus something something. So you can check like what you are at here I, and you want I minus 1, you want, like you can see here I minus 1 you required for calculating the I, dp of I, you need dp of I minus 1 as well as the dp of I minus 2. So it means when you are calculating the dp of I, you should know the value of dp I minus 1 as well as the I minus 2. Okay, so you, when you are calculating for this one, you should have the value of these two, then only you can calculate. So what, in which order you should reverse, like this way or this way? But like, I mean, you calculate from, like, you should calculate from I equal to 0, or you should calculate from I equal to n minus 1. There are two ways. Now you can calculate from here to here, 0 to n minus 1, or you can calculate n minus 1 to 0. So this is I minus 2, this is I minus 1, this is I plus 1. Okay, suppose. So as we, if suppose, as we need I minus 1 and I minus 2, if you calculate from this side, when you will reach this I, you will already have the value of I minus 2 and I minus 1. Okay, हाँ नहीं. So if you come from this side, you, at whenever you will reach at I, you already have the value of I minus 2 and I minus 1. Okay, so this is the optimal way to iterate. And suppose there is I plus 1, some I plus 1. Okay, suppose there is I plus 1, then I plus 1 and dp of I plus 1 and I plus 2. Then in this then you should travel from iterate from this side, because if you travel from this side, when you will reach at I, you will already have the I plus 1 and I plus 2. That's why. So this is the key thing you should know. So as we have decided, we should read from here to here, means like 0 to n minus 1. We will iterate through this way. As we have already discussed for 0. So this is dp of 0. Now I am writing the for loop dp of I minus 1 to n. Okay. Okay. So first case, if we don't take the value, then what comes? If we don't select the value, this is nothing but dp of I minus 1, as you discussed here. If you not loot, it will be dp of I. So okay, this part is clear. If you don't not take, dp of I is equal to dp of I minus 1. One more thing, this if loop is like unnecessary, because as we have already defined here, I equal to 1 to n, but still, this is the key, like this is the mistake that students do. Like if you are writing here dp of I minus 1, sometimes it's happen if you don't add this condition and it is running for I equal to 0, then it will be 0 minus 1 minus 1 dp of I minus 1, and it will say the runtime error, because dp of minus 1 is nothing, like index is not defining index out of bound error you get. So that's why if you are writing anything, you should write condition for that also. Okay. So this is the condition that we are at. Now if we take what we have decided here, dp of ar of I plus dp of I minus 2, here it's come properly. So this is the condition that, okay, dp of I is equal to ar of I plus dp of I minus 2. If I is greater equal to, suppose we are at this we are at this index, so we can simply say 5 plus whatever we get from here. Okay. But suppose you are at here, you are at this is index 0, this is index 1, this is 2, this is 3. Suppose you are writing dp of 1, then what you will write? Arr of 1 plus dp of 1 minus 2, that is minus 1. It will say the index out of bound. Okay. That's why if you are at here, what you should write? You should write dp of I and AR of 5, because if you are at here, dp of minus 1, if you are if you take this 5, if you take this 5, you won't be able to take this 6, and there is nothing left. So that's why only error of I. So that's why I'm saying, like, write the conditions properly. Like if I minus 2 is there, then write separately for I greater equal to and else. This is a key thing. And we are taking the maximum, so that's why I have kept maximum over here and over here, because we are taking the maximum, because we are taking maximum if you loot I and if you don't loot I. So that's why we are taking the maximum. So this is the way. And what our answer will be like, answer will be, we are at here, and what the maximum money we can loot, that will be told by the maximum amount of money thief can get if he is at house I. So he is at house n minus 1, and now what is the maximum amount of money he can get? So that's why answer will be written dp of n minus 1. If you talk about the time complexity, and so time complexity, this is, we have only run one, we have already implemented only for loop, so time complexity will be order of n only, and space complexity will be order n only. Space complexity will be also, because we have initialized a dp array. Okay. So this is the thing. Yeah, iterative code is a little bit tricky, and this trick you can learn from here. Like, you should iterate from where to where. You can learn from the here, like whatever needed at I, according to that you can decide from which side you should iterate. Okay guys, thank you, bye bye. Please subscribe my channel if you want to see the solution of daily POTDs. Thank you.